We will now proceed to the types of chromatography. The first one is the column chromatography. So what you see in the illustration is the chromatography column itself. This is actually a glass cylinder with bulb and a ground glass joint on top and tapered joint with stopcock at the bottom. The following are the parts of the chromatography column. First is the ground glass joint, this is used in the laboratory to quickly and easily fit leak-tight apparatus together from the common available parts. The next is the solvent level, where the solvent travels up the matrix by capillarity, moving the components of the samples at different various rates. So the next one is the solvent valve, which serves as the vacuum source for filling the reagents through a pipette, and this is also helps to control the flow of liquid from the dropping bottle. Next is the sand, which is used to protect the silica gel surface, the column, which is the silica gel itself, and the cotton, which is to prevent escape of silica gel. And lastly is the stopcock, which has the same function as for the solvent bulb. The only difference is that ang valve dito is designed to completely stop the flow kapag na-close na siya fully. For the history of the column chromatography, this was developed by the American chemist D.T. Day in 1900s and also Michael Chuet, the Polish botanist. And during 1906, this is used as an absorption columns in his investigations of plant pigments. So, Michael Chuet actually washed an organic solution of plant pigments through a vertical glass column packed with an absorptive material. After that, na-discover niya na yung mga pigments is nag-separate into the series of color bands on the column divided by the regions, entirely free of the color. All in all, column chromatography is a separation technique in which the components of a mixture is separated by using a glass column packed with a stationary phase and the liquid mobile phase flowing continuously through the column. So this is why this is considered as one of the most successful methods for the separation and purification of both solids and liquids. So this is also a solid-liquid technique. When we say solid-liquid technique, this is in which the stationary phase is a solid while the mobile phase is a liquid. One of the important parts of the column chromatography is the column itself. So the main function of this is to support the stationary phase. The material of the column is mostly good quality neutral glass since it shouldn't be affected by the solvents dapat. Otherwise, an ordinary burette can also be used as a column for the separation. For the column dimensions, the length and the diameter ratio is the following: 10:1 or 30:1 or otherwise 100:1. So various accessories are attached to the top and bottom of the column for maintenance of the elution process. The length of the column actually depends upon the following. First is the number of compounds to be separated, pwede rin yung type of adsorbent used, and the quantity of the sample, gaano kadami. And lastly is the affinity of compounds towards the adsorbent used, because better separation will be obtained with a long narrow column compared sa mga short thick column because number of plates will be more. There are two types of preparing a column. The first one is the dry packing or dry filling, and the other one is the wet packing or wet filling. But before that, there are some reminders na dapat alalahanin bago mag-proceed sa process. The first one is that the column should be free from impurity. Before using the column, it should be washed properly and dry it. Another one is before filling column with stationary phase or the solid phase, cotton or glass wool is kept. And lastly, it should be uniformly filled. The first method is the dry method. So in dry method, at first, the column is filled with dried powder silica. Then the mobile phase or the liquid phase, a suitable solvent is flushed through it until all the silica are wet and settled. From this point till the end, always the column need to keep wet with solvent. So you need to fill the solvent until the equilibrium is reached. So once na napuno na, you can tap it to remove the void spaces. On the other hand, wet packing and wet filling, this is the ideal and common technique. This is where firstly, a slurry of silica and solvent is prepared and then poured into the column using a funnel. So more solvent must be used dapat until the silica is settled into it. Additionally, sa wet packing or wet filling is the stationary phase nagasettle uniformly, and compared sa dry packing, there is no crack in the column of the adsorbent. Other than that, the solid settles down while the solvent will remain upward. Tapos yung solvent na yun is removed, then again, cotton plug is being replaced na. Chromatography consists of the two phases or the adsorbent, which is the stationary phase and the mobile phase. Ang stationary phase, this is the solid particles. This is a glass tube with a circle inlet and a small outlet with a plug or top. Basta mostly mga solid substances to sila. Some of the examples of this are the silica gel, calcium carbonate, cellulose, and the starch. Wherein ang mobile phase naman, this is the liquid. This one acts as a solvent, developer, and the eluent. Example of these are the following: cyclohexane, benzene, chloroform, esters, and water. How does it work? So, column chromatography actually works in few steps. The first one is that mixture to be separated is dissolved in the mobile phase. So, the mobile phase or ang ating liquid phase is dapat solvent or solvent mixture na. Other than that, the upper level of mobile phase should be the same way as the stationary phase. Meaning, the stationary phase is dapat wet na rin, the same as true with the solvent. On this stage, the compound mixture what need to be separated are added from the top of the column in such way na dapat hindi madisturbo or hindi madisturb yung nasa top level nito. The second process is that mobile phase is added throughout the process. After malagay yung mobile phase sa top, the solvent or suitable solvent mixture is added at the first touching the side of the glass column slowly and carefully so that the top level of the stationary phase is not disturbed. After that, the solvent is repeatedly added as many times as needed throughout the process. The third step is the components separate na. So dito, when the top is on the compounds, it will move along with the eluent or the liquid phase depending on the polarity of the sample molecule. The non-polar components travel faster than the polar components. So suppose if any compound mixture contains 3 compounds, so kunwari ito, the blue, red, and green, according to the polarity of these compounds are, ang first is blue, red, green, meaning that the blue is the most polar compound and thus will have the less tendency to move along with the mobile phase. As you can see in the illustration, the green colored compound will travel first as it is less polar than the other two, the red and the blue. When it is near the end of the column, a clean test tube is taken to collect the green sample. Ito yung parang test tube. And after that, this is the red, and at last, the most polar blue compound is collected, all in separate test tubes. Thus, a compound mixture is separated or purified by using a column chromatography na. For the substance assay, the following substances are used: the acetaminophen elixir USP and also the amphetamine. For the summary of the column chromatography, this is a chromatography technique that is used to separate mixture of chemical substances into its individual compounds. This consists of two phases: the mobile phase or the liquid phase and the stationary phase or the solid phase. So, one of the parts of the column chromatography is the column, which is prepared by mixing the silica with suitable solvent and poured it into a glass of the column. So, a suitable solvent or the mobile phase is moved along with compound mixture through the column according to the polarity. Remember lang na the non-polar components travel faster than the polar component.